So hi everyone, let's read this question first. A 4 centimeter tall object is placed on the principal axis of a convex lens. Now draw the convex lens. Draw the convex lens. Okay. This is the principal axis, optical center. Okay. Clear? The distance 4 centimeter tall object means HO is height of object is 4 centimeter plus. The distance of the object from the optical center is 12 centimeter. It means U will be minus 12, and its sharp image is formed at a distance of 24 centimeter from it on a screen on the other side of the lens. So there is a screen. Clear? On a screen is there a screen, and on this screen an image is formed. Image is formed 24 centimeter. Okay. Reading question is a very good skill. Object is here, so always read the question first. This is 12 centimeter. V will be plus 24. If the object is now moved a little away from the lens, later we will see this. First of all, find the focal length. Now from the object is 4 centimeter. Clear? You will draw the incident ray like this. So you can check focal length. How much focal length? What is the focal length of the lens? 1 upon f is equal to 1 upon v minus 1 upon u. Clear? Now calculate the focal length and give me the answer. 1 upon v. V is, we are going to measure v in the direction of incident ray. So it will be 1 upon 24 minus u will be negative minus 12. So just solve this. 1 upon f is equal to 1 upon 24 plus 1 upon 12. So LCM will be, you don't know? Okay, 24 multiply 12. Take 24 plus 12. F will be 24 multiply 12 divided by 24 plus 12. It is 36. 12 3s are 3 1 3 8s are. It means focal length comes out to be 8 centimeter. It means our focus will be here. Focus is here. This is 8 centimeter. And double of focus is 2f. That is center of curvature. Okay, so it will be 16. It means object is placed between focus and the center of curvature. Then image will be beyond 2f. You can check also. 24 is more than, here also 2f. Okay, here f. So 2f is this 2f. 16 images at 24 beyond 2f. That's what you have learned. It is 8 centimeter. Is it clear? Now what they are saying next part, this is screen. Okay, this is screen. On a screen, image is going to form. Let's read the question. If the object is now moved, read the question carefully. If the object is now moved a little away from the lens, in which way towards the lens or away from the lens will be have to move the screen to get a sharp image of the object on it again. You tell me, if you are taking this object in the left direction, then image is coming. If you are taking the object left direction, then when it is at 2f, image is at 2f. When the object is beyond 2f, image is in between f and 2f. Now you can check when you are increasing the object distance from the mirror lens. object distance from the lens, then image distance is going to decrease. The reason is that even if you don't know this concept, like you just understand 1 upon f is equal to 1 upon v minus 1 upon u. If you increase this, if you increase the u, then obviously v must be decreased because focal length is constant. It will not change. Then you have to move this screen towards lens like this. Then only you will get a sharp image. Okay. So when object is going away from the optical center, then away from optical center means our object is beyond 2f. Initially it is at between f and 2f. When it is going away from the lens, then it is our object is beyond 2f. Beyond 2f means image will be between f and 2f. Or when object is at 2f, image will be at 2f. Earlier our image is beyond 2f when object is placed between f and 2f. But when you move this object in the left direction, when it is going away from focus, then image is shifted like this towards lens. Okay, if you increase u, v has to decrease. Then only 1 upon v minus 1 upon u will not change. Focal length remain constant. Okay, then it is 100% sure if you increase u, v has to decrease. Vice versa. If you decrease u, then v has to increase. Clear? If you take the object towards lens, then image is going to shift away from the lens. That's what you have learned. When the object is at focus, image at infinity. Clear? When the object is in between f and 2f, image is beyond 2f. So if you are going towards lens, image is going to shift away from the lens. If you are going away from the lens, image is going to shift towards lens. Clear? So magnification, how will the magnification of the image be affected? So you tell me, magnification is what? V by U. So when, for example, you are increasing U. You are increasing U. That's what you are doing now. Then you increase. Let us suppose you increase initially like 12 centimeter. Now you increase more than that. Let us suppose our object is U is 20, not 24. You can take 25. Clear? Then U is 25. Obviously, V will be less than 25. Clear? V will be less than 25. So magnification is decreasing. It is less than 1. Clear? If you increase U, V is going to decrease. Then this ratio is going to decrease. If you are going away from the lens, then magnification is going to decrease. The size of image, initially it is this, it is going to decrease while going towards lens. The size of image is going to decrease. Clear? So answer is, how will be the magnification of the image will be affected? It will decrease. It will decrease. Okay. I hope this is a detailed solution. Still you have doubt, please ask in the comment section. Solve such question because it will increase your IQ level and understanding power. Because if you understand at this time, then you can perform well in your board examination. Okay. Thank you so much. Thanks a lot.